All right, hello everyone. So today we have the following problem. Two pumps are emptying a pool. One pump can empty the pool in 5 hours by itself, and the other pump can empty the pool in 8 hours by itself. If the slower pump breaks down after 2 hours, how long does it take the faster pump to empty out the pool? Okay, so rate problem is like an algebra problem, I guess you could say. Now, for the solution for this problem, we're going to need the following. I'm going to bring out this equation. D equals R times T. In other words, distance equals rate times time. Okay. You might say, well, what does that have to do with this problem? I'm not talking about people running or anything along those lines. That equation actually applies here as well. Yeah, if you take how fast someone, let's say, is running and multiply it by the time they ran, it tells you the total distance they ran. Similar idea here in the sense that if you take a rate of how fast it takes them to do a job, okay, times a total time they've been working on the job, and that tells you how much of the job they've done. Okay, now here we have two rates. Okay, I'm gonna say rate of the fast pump and the rate of the slow pump. Okay, now the rate of the fast pump, I would say, is as follows: is 1/5 and 1/8 for the rate of the slow. So why 1/5 and why 1/8? Well, think of it this way: if the fast pump does the job in 5 hours, in 1 hour, it's done 1/5 the job. So you can think of this as a rate as 1/5 of the job per hour, and likewise, the slow pump has done in 1 hour 1/8 of the job. Okay, so that's what this would represent in a sense. So if you take those two rates and you multiply it by the time, that tells you how much of the job has been. So for example, if you take the faster pump and let's say you've been working for 2 hours, then how much of the job has the fast pump done? If it's 1/5 of the job per hour, well, 1/5 of job per hour times 2 hours would be 2/5 of the job. Okay, yeah, think of it this way as well: the hours would just cancel and you would have 2/5 of a job left here. Okay, so that is what we're going to be using here. So that same principle. So the question here for us was how long it took the faster pump to do the job by itself, essentially, after the slower pump breaks down after 2 hours. Well, there's the thing: if the two pumps were working together for 2 hours, we want to know how much of the job they've done in 2 hours. Well, this is what I'm going to use. I'm going to use that same idea: job equals rate times time, or time times rate, whichever. So if you take 2 hours and you add the rates together, and we're adding the rates together because both of them are working together, that's how much of the job has been done in 2 hours. Okay, that's what that represents. And what would we have out of this? I'm not going to do the addition with the fractions here. I'll let you work on that. When you add the fractions, you get 13/40. So 2 times 13/40 is 13/20. Okay. So they've done 13/20ths of the job. So how much of the job is left to do? Well, if you had one job to empty the pool, well, if you subtract what you had done already, you've done 13/20ths, you have 7/20ths of the pool left to pump out. So that's how much the fast pump has to do. in terms of like, yeah, how much the job has to complete. So the question is here, how much time would it take to complete that job? Well, the job that it has to do is 7/20ths, right, of the pool remaining to empty. Well, the rate is 1/5 of the job per hour times the total amount of time, which we do not know. That's what I'm looking for. And you're just going to solve this. And if you solve this, you would get 7/4. You multiply both sides by 5. And you get 7/4, but usually, and this is in hours because that's what our units of time are. However, we don't usually leave answers as improper fractions with these word problems because it's kind of weird to say, oh, I finished the job in 7/4 hours. So another way to say this would be 1 3/4 hours. You write it out as a mixed number. Or 3/4 of an hour is 45 minutes. So an hour and 45 minutes, okay, is how long it would take the fast pump to finish the job by itself after the slow one broke down. So total, the whole job would have taken 3 hours and 45 minutes because you already had done 2 hours plus the hour and 45. However, that's not what the question was asking. But sometimes they do ask that type of question here. I have a video, and I'll link it to this one here, and you should be seeing it in a few seconds after this, where you have another job problem, but it's a little easier. It's just two people working together trying to paint a house. But it's an easier kind of setup than this, so if you're asking yourself, if you're not quite understanding some of the steps, I'll link that video so you can take a look at that. Okay, thanks for your time.